So, AI agents. You've probably heard that term popping up everywhere, right? And usually it's wrapped up in all this hype, a little bit of sci-fi, but what are they, really? The whole conversation can get pretty confusing, so in this explainer, we're just going to cut straight through all that noise.
You know the story you hear all the time? That an AI agent is basically a digital employee that you can just hire to run parts of your business on its own. And look, that's a really exciting idea, but it's also where a lot of the misunderstanding starts. So let's clear that up right now.
Okay, right off the bat, an AI agent is not a digital person. It's not some kind of thinking being that you can delegate tasks to like you would a human. To really, truly understand what they are and what they're actually capable of, we've got to look under the hood at the mechanics. And when you do that, you know what you find? A formula that's surprisingly simple but really powerful. At its absolute core, an AI agent is just three things. You've got a large language model, or LLM, that does the thinking. You've got a set of tools it can use to take action, and you've got a feedback loop that lets it try, learn, and try again. That's it. That's the whole shebang. LLM, tools, and loops.
All right, so let's dive into that formula. We're going to deconstruct what an agent actually is, piece by piece, so we can build a really practical, ground-up understanding of how these systems work.
So here's the good, solid definition for us to work with. An AI agent is a system that uses an LLM to create a plan and then execute it step by step, using external tools to get to some complex goal. And the keywords there are really system and step by step. This is all about a structured process, not some magical spark of intelligence. And that process looks a lot like this. First, the agent gets a task. Then, the LLM inside it comes up with a plan. It takes the first step using a tool, and then, and this is the critical part, it observes the result. Based on that new info, it loops back, thinks again, and decides the next step. This think, act, observe cycle just keeps going until the job is done. That loop, that's the real heart of the agent.
Now, that might still feel a little abstract, so let's make it super concrete. We're going to walk through how a simple research agent would try to answer a question, just so you can see this whole workflow in action.
But before we get into the nitty-gritty, let's look at the high-level blueprint. This diagram actually comes from the really influential Generative Agents paper, and it shows the formal architecture. It's a constant cycle, right? The agent perceives what's going on, retrieves data it needs, and then it acts. That action changes the situation, and then it perceives again, starting the whole loop over. You can actually boil that whole complex diagram down into this powerful little mantra from the React paper: thought, then action, then observation. For every single step the agent takes, it follows this pattern. It thinks about what to do, it does it with a tool, and it sees what happened. Now let's see that in practice.
In this table just illustrates it perfectly. So the agent is asked, did the actor Nikolai Coster-Waldau work with Fox? Let's follow its logic. Step 1, in the thought column, it thinks, I need to find this out. So its action is to use the search tool. The observation is what comes back from the search. A result mentions a Fox television series. Now the loop starts again. Step 2, the new thought is, okay, that observation confirms it. So its final action is to call the finish tool. Task complete.
So you see the crucial point here. The agent's real power doesn't come from one big, brilliant insight. It comes from calling that LLM over and over and over again in a loop. Every single call is just one small step. Process what just happened and decide what to do next. It's a workflow.
Okay, so now that we get the mechanics, we can ask a much more practical question. What are these agent workflows actually good for today? Where do they really add value?
Well, first, we have to remember an agent is only as good as its tool belt. It can't just magically do things. It has to be explicitly given tools, like access to a web search, or a connection to your company's database, a code interpreter for math, or even APIs for sending an email or checking a calendar.
So given those tools, the best tasks are ones that look like a recipe, a repeatable sequence. Think about doing complex research. Search a source, summarize it. Search another, summarize that, then put it all together. Or maybe analyzing a long legal document. Extract the key clauses, check them against a policy, and then flag any issues. You see? They're all structured workflows, a perfect fit for that thought, action, observation loop.
But it's not all seamless automation. To get a truly realistic picture, we have to talk about the limitations, which are very real. Because for all their power in the right context, agents can also be incredibly fragile. And the first problem you'll hit is a really practical one: cost and latency. Just remember,
Every single step in that loop, every single thought the agent has, is another expensive, time-consuming API call to a giant language model.
And that cost adds up fast. A single query to an LLM might be pennies, but a simple agent task could need 5, 10, maybe 20 of those calls. A complex task, it could be hundreds. Not only does this get very expensive, it makes the whole process feel slow because it has to wait for a response at every single step.
The second problem is a little more subtle, but honestly, it can be much more dangerous. It's called error propagation. And because an agent's work is a chain of steps, one bad link at the beginning can break the whole chain.
It always starts with something small. The agent misinterprets one tiny piece of data, or a tool gives it a slightly incorrect result right at the start of the process.
But because every single step that follows builds on the last one, that little error starts to snowball. The agent is now making its next decisions based on faulty information. And by the time it gets to the end of the chain, that tiny initial mistake has cascaded into a completely wrong answer, or the whole task just fails entirely.
And this isn't just a hypothetical. The research from that generative agents paper confirms this fragility. They found that agents can fail to remember the right info, or even worse, they can hallucinate embellishments. That's just a fancy way of saying they confidently make things up that sound plausible but are totally wrong, poisoning the entire rest of the workflow.
And that brings us to the third big limitation, a lack of generality. You have to think of agents as specialists, not generalists. They're designed to follow a very specific kind of plan with a specific set of tools. The moment they run into something they weren't designed for, they tend to break.
Look at it this way. On the left, when a task is defined nice and narrowly, everything works just fine. The plan makes sense, the tools are right for the job, success. But on the right, something unexpected happens. The data's in a weird format, a website is down, the goal is a little fuzzy. The agent just can't adapt. It doesn't have a tool for deal with weird new problem, and the whole process just grinds to a halt.
So, with all that in mind, the mechanics, the strengths, and the very real weaknesses, what's the practical takeaway? How do you know when it actually makes sense to use an AI agent?
Well, it really comes down to this simple comparison. Agents are a great fit for repeatable workflows where the steps are predictable. They're good when you can check their work along the way, and for low-risk automation where a failure isn't the end of the world. But they are a terrible fit for any task that needs general intelligence, true autonomy to handle surprises, or, and this is a big one, anything that needs to be 100% correct, guaranteed.
This leads us to what might be the most important mental shift you can make. The question to ask isn't this vague, can an agent do this? The right question is, can I define this task as a repeatable, step-by-step workflow, a recipe that a large language model can follow with a clear set of tools? It's a question about engineering, not about magic.
So ultimately, this is the clearest way to think about it. AI agents are basically workflow automation, just supercharged by an LLM. And that means they are incredibly powerful when they're narrowly scoped to the right kind of problem. But they're also incredibly fragile when we get carried away by the hype and try to misapply them. And understanding that distinction, well, that's the key to using them effectively.